Welcome to Windows AzureConf. My name's Eric Boyd, and over the next 60 minutes, I'm going to be talking about how you can debug and monitor your Windows Azure cloud services. A little bit about me before we begin. I run a consultancy in Chicago and Milwaukee called ResponsiveX, and all we do is help customers build web, mobile, and traditional client apps built around Windows Azure. I'm also a Windows Azure MVP. And if you'd like to contact me, you can read more about what I have to say on my blog at ericdboyd.com, as well as on Twitter at ericdboyd. One thing I would like to point out before we get started today and too deep is this coming weekend, April 27th, this Saturday, is a global Windows Azure boot camp. And Global Windows Azure Boot Camp, what that means is around the world there will be boot camps going on that you can spend an entire day with trainers and people who live and breathe Windows Azure and know this stuff in and out and get you hands-on with Windows Azure, get you started building applications on Microsoft's cloud platform. So definitely don't miss this. They're going on around the globe. I'm hosting one in Chicago, so you should check this out at globalwindowsazure.azurewebsites.net. If you're in Chicago, check out chicagocodecamp.com, which is where we're hosting the Global Windows Azure Boot Camp in Chicago. All right, our agenda today is pretty simple. I'm going to talk about Windows Azure Platform as a Service, which is cloud services in Windows Azure. And I'm going to talk about debugging the application issues that you may run into as you build applications just like you would on premise today, run into bugs and defects and issues. And then we'll also explore how we can debug and identify performance problems in Windows Azure. Now, what is a cloud service? A cloud service is a platform as a service in Windows Azure. We often hear the term PaaS. And what that means is it's an abstraction over hardware. We have an API that we can use to build applications in the cloud. So it's great for developers. We don't have to worry about the infrastructure and the VMs and the OS and that sort of thing. We can just work with this API and this abstraction layer over all of that. Underneath the covers, what we get is a VM, but that's presented to us in two forms today in Windows Azure. One, a web role, which is basically a web server running IIS, and a worker role, which is a good place to host background processing and other application servers that you just may want to pop up in Windows Azure in a cloud service. So maybe you want to host your own web server, that sort of thing. A worker role works really well for that. Now, having said that, it's important to understand that the cloud services are stateless. They are not persistent VMs like you would expect in infrastructure as a service. So while underneath the covers they are VMs, they're not persistent. So any data that gets stored and created during the lifetime of that cloud service, of that VM instance, when that reboots or recycles for whatever reason, that data is lost. So it's important to understand that. That matters as you're building applications. So it's not exactly a VM like you would have on premise or in an infrastructure as a service offering like Windows Azure Virtual Machines, but underneath the covers it is hosted up in a VM. When you're developing on premise, or rather in your development environment, you have an emulator for Windows Azure Cloud Services. And this is the compute emulator that emulates and provides you an environment to debug applications that you're building locally on your own machine. This is really useful. You'll see this console output here, but this is really useful for as you're building applications and debugging them in your physical development environment. You can see output coming from your applications and trace issues out to this console window, and that helps debugging your cloud services. Now, I mentioned it is in fact a VM, and so just like you would expect in any other server or virtual machine, you do have options and controls like you would in a VM running in Hyper-V or another virtualization platform. So things like rebooting that VM. You also have an option to reimage a VM, and then right in the middle you can connect an RDP into this VM. And so let's do just that. I'm going to flip open here a project that I have running in Visual Studio, and while I do that, let me crank up There we go. So here in Visual Studio, I have a very simple web app, and I'll show you that web app here in just a second. But what I want to do is deploy this out to Windows Azure Cloud Services, and I want to be able to RDP into my cloud service, into my VM. So this is my MVC project here. Very simple. I have a couple of controllers, just like you would expect to see in a normal MVC app that you would run on premise. There's nothing special about the MVC app in and of itself. And then I have this Azure deployment project. So this is my package for my cloud service. And it's mapped back to my web role, my MVC app, and that is going to be my package for deployment. Now when I go through this, I can say, let's publish this application, and I'm going to go back to the very beginning here, and I can choose the subscription that I want to deploy this to out in Windows Azure. So that's the subscription I'm going to choose. And then I can choose the exact service out in Windows Azure, and I'll show you the portal here in just a minute as well. But when I go through this publishing wizard, I can choose Enable Remote Desktop, and that will allow me to connect into that virtual machine running out in Windows Azure. And so that allows me to do things like look at the event log, look at the machine and any files on the machine, copy to and from, that sort of thing. Now when I choose that, what that does underneath the covers is it imports a couple of modules. So this is my CSDef, which is my cloud service definition. This is kind of what defines my service, and you'll see here I have these two modules, remote access or remote forwarder, and those get added when I choose to enable RDP. Now if I also look at my configuration file, you'll see I have configuration for remote access as well. And so I have a username, I have an encrypted password, I've provided a password during that wizard, and so if I go back to that, and I click settings here, you'll see I can choose the password and the username and when this account should expire. So if I go publish that and connect in, so this is my cloud service out in Windows Azure in the Windows Azure Management Portal. If I click this connect button at the very bottom, this will prompt me to RDP into that instance. So if I say connect, and log in with the password that I provided, I am looking at a Windows Server 2008 R2 in fact, just like I would have on premise. I can look at the file system, dig into what's going on here. I can take a look at IIS, so there's some websites that I have running, just like I would on premise. So I do have access to this VM via RDP and remote desktop. Now, let me flip back to slides here. Now while we can get access via RDP and we can remote into this server that is kind of powering our cloud service, that may not be practical for us. And so this is the challenge that we have. In cloud services, one of the benefits that we get is the ability to scale on demand and scale massively. And so you may have a scenario where you have a web farm with 4 or 8 or 10 or maybe even 100 web servers, or maybe you're doing some back-end processing with hundreds or thousands of servers. And so RDP breaks down when you start talking about scale, because now you have to identify the exact server that you need to connect to, and then you need to go connect that and browse to that server in a big list of instances and RDP in. And so it becomes really challenging when you start doing this at scale. The good news is Microsoft's provided us with some diagnostic capabilities in Windows Azure to aggregate all of that information and centralize it in one spot. And so this is a list of all of the Windows Azure Diagnostics sources that we can leverage today. And so Windows Azure Diagnostics is a module just like the remote access and the remote forwarder module that we were just looking at that allowed us to RDP into our instances. Diagnostics is also a module. And so with Diagnostics, we can configure a lot of different logging. We can say I want some infrastructure logs that would capture information about the modules like remote access, remote forwarder, and diagnostics. We can capture event logs. So anything that you would see normally in the event viewer, so application logs and system level logs that are in the event viewer, you can aggregate that as well and centralize that. We could look at Windows Azure logs and capture application trace messages using trace listeners, and I'll show you how to do that as well. And then we also have some IIS logs, so just normal IIS request logs, as well as failed request logs. We could capture performance counters as well and aggregate those from multiple servers, as well as crash dumps. And then lastly, if we needed to capture our own custom logs, so maybe we create a file, maybe it's Log4Net or some logging framework that we're using, we can capture that as well and aggregate that and centralize that in one spot. So with that, let's go take a look at Windows Azure Diagnostics. So I'm going to close some windows here. All right. Just going to collapse this down. All right, first thing first, we have a module here that we import called Diagnostics. By adding that import into our CSDef, we get that module packaged up with our CS package and our deployment to Windows Azure. The next thing that we need is a path to store all the diagnostics data to. And so you'll see that that diagnostics module also provides us with a connection string, this Microsoft.windowsazure.plugins.diagnostics.connection string. And this connection string is what is where we want to store all of our data that's aggregated from all of the instances. So all of the logs, all of the event viewer and Windows event logs, any custom files that we would have, we're going to aggregate all of that to this one spot. Now this one spot is a Windows Azure storage account. And so we aggregate this from all of our instances and add that to a Windows Azure storage account. Now if we go back to our web application, we have a couple of things going on. So first thing, I'm going to go dig into the web role. Now this is a web role class, webrole.cs. This is part of the default cloud project. And you'll see this web role derives from role entry point. Now in a web role we have a number of methods to override that handle the life cycle of our cloud service. So first we have onStart, and we have things like run and onStop as well. But onStart happens when we fire up our cloud service for the first time. So when it loads up, when the instance loads up out in Azure, onStart gets called. And so what we're doing here is saying, hey, are there any trace listeners added that look like this? So Microsoft has provided us in the Microsoft.windowsazure.diagnostics namespace a diagnostics monitor trace listener. Now what that does is that takes all of our trace data that we would trace out just like we would normally in our applications, in our .NET applications. So any messages that we would trace out, and that aggregates that and stores that ultimately in Windows Azure storage accounts. So this line is saying if we don't have a trace listener that's a diagnostics monitor trace listener, then go ahead and add one. The next thing I'm doing is saying any unhandled exception that occurs in my application, execute this event handler, and this event handler is grabbing the base exception out of that exception, so the most inner exception, and then tracing that exception out, so the message as well as the stack trace. Alright, so let's go take a look at this in action. I actually have in my management portal a service that is over and over again recycling. So you may have run into these kinds of problems before where you deploy your cloud service to Windows Azure and it is just recycling over and over and over again. Now, in all fairness, just so you know, what I had here that's causing this to happen is I had a line like this. So I threw an exception in my onStart. I was executing some things at startup and I threw an exception. And that's what's causing my instances to recycle. So if I go over to the Server Explorer, I can expand out Windows Azure storage, and I can then go grab logs. So there's a WAD logs table here in the Server Explorer, and that is, WAD is Windows Azure Diagnostics. You'll see that throughout. But if I open that table up, you'll see here's my stack trace and my message that I logged out. So I have a message that says something bad happened, and there's my stack trace of everything bad that happened. So that's really useful when debugging issues with the life cycle of your cloud service. So when you're doing stuff in your web role or your worker role that derives from role entry point, it's really useful to capture all of those exceptions and trace them out. Now let's go look at a couple of things that's making this happen, because I haven't done anything to start up diagnostics. Now you could imperatively through code using diagnostics monitor configuration, you could configure diagnostics to collect all of your data. And so you could write out some lines to say add these logs, add trace logs, add infrastructure logs, and that sort of thing. But there is an easier way declaratively using some XML to do that. And so there is a file, a convention, that's diagnostics.wadcfg. And what this is the configuration for your diagnostics monitor in Windows Azure. And so you'll see I have infrastructure logs right off the bat. I have logs, the Windows Azure trace log capability, next. And then I have directories. So I have crash dumps and failed request logs from IIS, and IIS logs, so the request logs that come through IIS. And then I have some custom data sources as well. Now these are the ones we're going to focus on right now. I'm going to collapse up the rest of this. And at the very bottom you'll see I have Windows event log information as well. So I'm capturing these event logs, so applications, system, and Windows Azure. Now there's a couple of things that are interesting here. One, I get to define what level of messages I want. And so for example, in the event log I've chosen I just want errors to be aggregated to storage. And then up in the infrastructure logs I've chosen warnings to be aggregated. Warnings are better. The next thing that you'll see is the scheduled transfer period. And this tells diagnostics how often should I take these from the local instance and move them off to storage. Now you'll want to think about that a little bit. You won't want to set it too high. You won't want to set it terribly low because it will add some overhead and some I/O and some network I/O to do that. So for demo's sake, I have it down to 1 minute. You may choose 5 minutes, you may choose longer, but just remember that you have to be, whatever that period of time is, you have to be willing to lose that period of time worth of logs, because at any time, in an upgrade scenario or a failure scenario, if your cloud service VM dies, that state is lost, and so it won't get transferred to storage. So you have to keep that in mind as you're configuring this. All right, we talked a little bit about the Windows Azure Diagnostics trace listener in the web role. We are next going to look at instrumenting code inside your application as well. And we are going to also look at how we would do that with custom log files with Windows Azure Diagnostics. So something we need to keep in mind here and think about is kind of how those files, how those custom log files get generated, where we store them, and how we move them off to blob storage using Windows Azure Diagnostics. Now, you could use any sort of custom log file generation that you would want. So for the sake of demo, I have just a simple class that's writing files to the file system. But you could use something like log4net or the intlib application blocks for logging, or some other framework that may be suitable for your needs. As long as files are getting written to the file system, it really doesn't matter where they come from or how you create them. The second thing is where you store them. And so the log files need to be stored in a local storage resource. I'll show you that here in just a little bit, how to configure that. But what this basically means is when you configure your cloud service, you can carve out a chunk of storage that you have access to on the instance that you can store files and write files to. And that's what a local storage resource is. I heard Corey Fowler today say it's a scratch disk, because it is. Again, these instances are not durable, so if an instance dies, that local storage will die as well, so those log files will be lost. So it is a scratch disk, but it's a temporary space that you can use and write files to that will ultimately get copied to persistent storage in Windows Azure Storage. Now the last thing is we have to use Windows Azure Diagnostics and configure Windows Azure Diagnostics to sync those log files to Windows Azure Blob Storage. So with that, let's flip back over and take a look at how we do that. So in our web role, we looked at tracing out some messages using just typical trace diagnostics infrastructure in .NET. But we also want to capture any trace messages across our application. So the way we configure that here is using, this is our web config, this could be an app config as well if you were doing a worker role and you just had a background service running in a worker role. But using system diagnostics in our application configuration, we can add listeners and trace listeners. And so we have the Microsoft Windows Azure Diagnostics Monitor Trace Listener. The same thing that we added imperatively in the web role entry point, we are adding declaratively in the configuration in our web config. And so there's the Diagnostics Monitor Trace Listener. And so that's basically saying anything we write out, anything we trace out will get picked up by this listener, and then the listener will do its thing and store it appropriately so that it'll get transferred off to Windows Azure Storage. So that's the first thing that we do. Next, let's go look at how we log this stuff out. So I want to show you another error that we have. Before we do that, let me just show you the application in an ideal scenario. So this is the working version of this application. So it's a little HTML5 cars app, nothing special. This application is going out to an OData service that gets data from a Windows Azure SQL database and gets images from Windows Azure Blob Storage, and then returns them up using MVC in a web app. So nothing terribly exciting. If I go over to my controller, this is the controller that's doing all of that work. So if I were to add an exception here and say bad error occurred, and I would deploy this out to Windows Azure, we're going to get back something like this. And so this is that chunk of code added into our application, returning this exception when we browse to that controller. So just a home controller here, an index right here, is throwing this exception for us. Now, we may, instead of returning this exception to the users, we may have some custom errors going here and present them with a nice friendly error message, but we would still want to know what happened. We're also not seeing the screens that our users are seeing, and so we need to collect all of those exceptions. And one of the ways to do that is using the onException override in a controller, in an MVC controller. So this is controller specific, but we can capture exceptions that occur in this controller. And so in this case, we're grabbing the exception context that comes in and then grabbing the exception off of that. And then, just like we were doing in our web role CS, we're getting the innermost base exception, and then we're tracing that out. We're tracing the message out and the stack trace out. Now you could also do this in your global ASAX, and you could do an application error event handler and capture errors across your entire application. That's a perfectly fine thing to do. In this case, I'm just doing this in one controller because this is the only controller we care about in our application. So now after doing that, if I go back over to our logs table and I view that, there's our error that occurred. Let me scroll this over a little bit. So there's the error that occurred in the stack trace for the exception in our startup, in our on-start of our web role CS. The next exception is the exception that we threw. So this is the exception inside of our controller. So again, we see a stack trace as well as our message that we printed out. So this is where an exception that we didn't throw, for example, just an unhandled exception, we would get the message and the stack trace for that unhandled exception. So we have a couple of instances of this. And we can use the tools, the Windows Azure tools for Visual Studio to see this information. Now, we've been looking at logs, but there are also infrastructure logs. So there's a table inside of our storage account called, they're all prefaced with WAD for Windows Azure Diagnostics, but WAD Diagnostic Infrastructure Logs table. If we view that, these are all of the logs that are related to infrastructure things inside of Windows Azure. So the modules like diagnostics, the remote access. In this case, I'm looking at performance counters. I can also go and look at event logs. So I view this table. Here's a list of event log data that came out of our application. And so you'll see the raw XML over here for the event. If I scroll this over, so this is just this big massive string of XML for the event that would be in the event log. And then you'll also see some other things that we'll cover here shortly, like performance counters and directories. So all of these things that are prefaced with WAD inside of storage, those are the things that come out of Windows Azure Diagnostics. So one of the things that gets created with Windows Azure Diagnostics is a container and blob storage called WAD control container. Now this is where the configuration for Windows Azure Diagnostics gets created. Now let's go take a look at that really quickly. If I go back to the Server Explorer, you will see if I expand out blobs, you'll see a container that is Windows Azure Diagnostics WAD-control container. If I open that up, you will see some files in here. These are all a listing of files that have configuration for our diagnostics. So if I open up one of these, I'm going to introduce you to a new tool. So thus far we've been working with diagnostics and looking at the diagnostics data inside of Visual Studio. The tool that I actually use day to day is a third-party tool from a company called Cerebrato, which is actually a part of Redgate. But they make a tool called Azure Management Studio, and before Azure Management Studio there were two tools. There was a tool for diagnostics and there was a tool for storage. And what they've done is integrated both of those tools together. And so now I have one tool for managing both of these things. So I can manage my storage account, copy files, very familiar, similar to something like Windows Explorer. And then I can also get a better visualization on the diagnostics data and the performance data. And so I'll show you both of those. So what you see here is, instead of a flat listing like we saw in Visual Studio, so this is just a flat listing of all of the files sitting in our container in blob storage, we get a hierarchical listing and a view that's very much like Windows Explorer. So if I expand this out, I can drill into this directory, and you'll see there's a file here that got created by diagnostics. Let me open this up and I'll show you what's inside. So this is our Windows Azure Diagnostics configuration. So all of the things that we did in our WAD config file, you'll see right here. So there's my diagnostics infrastructure logs, and there's my buffer quota, and there's how long my transfer period is. If I scroll down, I will see additional configuration for my event log, capturing the application and the system, and with the Windows Azure event log right here. If I keep going, you will see directories like crash dumps. You will see the Windows Azure Diagnostics IIS log files that it's capturing, the failed request logs, and that sort of thing. So all of that is here in this configuration. So what happens at startup, the WAD config file that's in your package gets sent out to this container, the WAD control container out in Windows Azure, and gets stored out in the storage account that you specified for diagnostics with your package. Now, that's important to understand, and let me tell you why here. By default, this is the precedence, this is the order of configuration for Windows Azure Diagnostics. So when your instance and your cloud services start up in Windows Azure, the first thing it's going to do is look at the WAD control container and look for a file that exists already for your deployment. And so the containers that were listed were all deployment IDs out in our storage account. So those identify our specific deployment. So it's going to look for a directory, a container that is your deployment. If it doesn't find that, then next it's going to look at your imperative code. So it's going to look for the code that you use to define how diagnostics should work. And if it doesn't find that, then next it will fall back and go to that WAD config file. So we can configure everything in that WAD config file, and that's how it's going to work at this point. And then if we don't have a WAD config file, so if we don't have an existing deployment with files out in our WAD control container, if we don't have any code to configure diagnostics, and if we don't have a WAD config, it will just use a default configuration that's very, very slimmed down. So it's important to understand that, because when you do an update to your deployment, if you make changes in your diagnostics in your WAD config, if there's an existing file out in storage, your changes won't get picked up. Now, this is kind of a funny photo, but what I'm trying to say here is, when accidents happen, when we have failures, somehow we need to go back and tease apart what happened. What happened with our application? What happened when it crashed? What happened when the exceptions occur? What happened that caused orders to stop coming in? IntelliTrace inside of Visual Studio Ultimate is a great tool for providing us that insight. So at runtime with your application, you can record everything that's going on with your application, the exceptions that occur, the call stacks that happen, the local variables, all of that sort of stuff, the information that's important to you in debugging the application, and you can play that back. And so what we're really looking for is taking that accident and getting flight recorder data out of it. We'd like a time machine to be able to go back and sit kind of right in the seat as these things are happening. And we would like DVR-like controls to play and pause and rewind and fast forward through the events that occurred in our application when an exception occurred. So with that, let's go take a look at how we would configure IntelliTrace in Visual Studio. I'm going to get rid of this exception. Go back over to our Windows Azure Cloud Services project here, our deployment project, and I'm going to say publish again. And in this publishing wizard, I can go to Advanced Settings, and under Advanced Settings I have some options. I have an option for enabling IntelliTrace, and I also have an option for enabling profiling. Now I can only have one or the other selected at any given time, but IntelliTrace is that flight recorder, that DVR-like control, that time machine, if you will, for us to debug our applications after the fact. So if I publish this out to Windows Azure, and I'm not going to do that for the sake of time, over in my Server Explorer, if I expand out Windows Azure Compute, you will see all the instances that I have running right now. I'm going to collapse these down. So I have a lot of instances of this application running right now. But if I have IntelliTrace or profiling configured on any of these, you'll see that in parentheses kind of out behind. Now, if I go back to my browser, you'll see that this HTML5 cars4.cloudapp.net application is returning this exception. And so if I go back over to Visual Studio, I can say, give me the IntelliTrace logs for this. And so if I right click on the instance and say view IntelliTrace logs, this is going to download logs from Azure, and it's going to allow me to, in Visual Studio, debug this application as though I were debugging it interactively and running into this exception. Alright, so now that that's done, it's given me a list of exceptions that have occurred. Now, there's my bad error occurred exception, and I can choose this exception and say let's start debugging it. You'll see here's my call stack for that exception. So there's a lot of ASP.NET MVC stuff going on here, system web. If I say start debugging this, I'm not going to load these symbols in, but if you look on the right hand side, I have information and a list of events that occurred in my application that I can start debugging right into. And so I can say, let's find some ASP.NET exceptions, or some events rather. And so here's my get event, and I could drill in here. Here's an error page that occurred. I can drill in and say show me the call stack, show me the local variables. And so over in my locals window, as though I were debugging this interactively in my application, I can see related to that event, here are the local variables. I can switch over to the calls view, and you'll see it's kind of nitty-gritty ASP.NET core functionality here in call stacks, but you can see I can drill into these and see the local variables and what have you as I'm drilling into the call stack. So I'm going to add all these back in. I can filter and search here as well. And there's this bad error occurred exception. I can go look at the exception that occurred. I just threw an exception, so there's nothing terribly exciting here, but I can dig into this and it will interactively inside of Visual Studio show me the lines of code that got executed. not just the lines of code, but I see the local variables as well. So here's the value of message at this point in time from this flight recorder, if you will, that's IntelliTrace. And so I can easily step through here after the fact and collect and debug the application from runtime, a runtime issue, and then I can walk through that and see the exact variables that got passed in. In this case, message was results count 2. I can go in and look at the exact values for all of the variables and walk through the stack trace. So it's a pretty useful tool. It's included in Visual Studio Ultimate. I can also take a look at profiling data. So when we looked at the publish settings, we had the option to choose IntelliTrace or profiling, one or the other. And so I've enabled profiling on some of them as well. So if I go back to my Server Explorer, you'll see there's a profiling instance. So I can right-click and say View Profiling Report, and that's going to show me performance of the application inside of Visual Studio. So we'll see a nice report and graph. In this case, there's nothing going on in my application right now. But if there were, I would see, let's just go make something happen. And let's grab this one. Let's grab a profiling report here. While that's loading up, there we go. So you'll see here's the methods that were called. There's kind of the time spent on specific areas of my application, and you'll see a graph of here's CPU usage that I can dig into using the profiling tools inside of Visual Studio. So that's really interesting. Like I can use this IntelliTrace functionality and, like a black box or a flight recorder, gather real call stacks and variables. I can take a look at the performance of my application without being there inside of the tools I'm familiar with using Visual Studio. All right, flip back to slides here for a second. Now we looked at profiling, but the other thing that we can do is capture performance counters. So we looked at profiling in terms of CPU usage across our application and our method calls. If I flip back to Visual Studio, one of the things I didn't show you were the settings on IntelliTrace and profiling. And so I have a couple of ways to configure that. And so if I am looking at IntelliTrace, I can tell IntelliTrace, don't capture that detailed call information with the call stack and the variable values, just capture the events. And so there's certainly a performance overhead associated with capturing that more detailed information using IntelliTrace. So you'll want to choose what makes the most sense for you. And then if I go into settings, I can choose on profiling, I can choose what I want to profile. So in our case, we profiled the CPU, and so you saw the CPU utilization across our functionality and our methods in our application. We could also say let's profile memory allocation or thread concurrency, and so we can configure IntelliTrace and profiling kind of to our liking, but we're not capturing detailed performance counters. So here in Visual Studio for our project, I can also capture performance counters in our WAD config. So here's a list of performance counters, and I'm just saying, hey, Windows Azure Diagnostics, I want you to grab these system performance counters every 15 seconds, and I want you to transfer them to storage every minute. And so all of these will get sampled every 15 seconds, and these are just built-in performance counters, and then transferred to storage every 1 minute. Now, we could also add our own custom performance counters in here. It's a little more work. We have to get the performance counter on the box created in our application, so it's not just there available, and then we can do this exact same thing using this syntax and add them into Windows Azure Diagnostics. But for the sake of demo, we're just going to use the built-in counters. So if I go back over to our storage account, you will see there's also a performance counter table. If I view this table, there's our performance counter data with a timestamp and the values and the counter name. If I go over to Azure Management Studio from Cerebrata, I get a much more robust experience. So if I open the dashboard for our application and say, yeah, give me the default settings here, you'll see a chart at the very top that shows us our perf counters that we've selected here. And so you'll see the values for our perf counters that are configured. So these are the ones that we've configured in Windows Azure Diagnostics. And now we can chart those out and see the values for those perf counters. So we looked at profiling, we've looked at perf counters. The other things that we commonly run into is database performance with Windows Azure SQL Database. Now, there are a lot of things that can occur in a SQL database. One, we may run into issues with our execution plans. Whether it's on-premise or out in the cloud, we may have some bad indexes or some hot queries that need some digging into. We also just may have issues with connections. So one of the things that happens out in Windows Azure in SQL Database is it's a multi-tenant database server, a database offering service out in Windows Azure, and so we have a lot of tenants sitting on the same box as us, and it is possible for the server to get hot from another tenant, and we get moved off to another node. And so we want to know what happens to our connections when our connections get dropped. We want to understand why that occurs. It's not something that happens terribly often, but it's important to be able to diagnose that and dig into why that's happening. So with Windows Azure SQL Database, there are some dynamic management views, just like you have in SQL Server on-premise, for database related views, execution related views, and transaction related views. There are also a couple of views in the database itself, so system views for looking at the connection stats. So what's going on with our connection, why a connection failed, and then there's also some events that occurred in an event log. So with that, let's go over and take a look at some dynamic management views. So this is, let me crank this up just a little bit. Here's some SQL. We're connecting to our Windows Azure SQL database running out in Azure, and here's our HTML5 cars database that's powering our web application. And then here's the master database as well. Now, using these dynamic management views, here's a list of a view of the connections currently to our Windows Azure SQL database. So there's my connection that I've just created, and there's my session ID and my connection ID and my CPU time that I'm using. If I ran this over and over again, maybe I could hit some CPU time here. So let's go back here and let's see what we've got going on. So now there's a whole list of connections that came out of our refreshes of our web app. Now, we may want to look at hot queries. And so you'll see we have some management views here for query stats. Let me zoom this up a little bit as well. So we're gathering these query stats dynamic management views as well as SQL. And if I run this, it'll show you my top queries. And these are the top 5 queries that I'm currently running. If I expand this out, let's grab some more. Here's the select that I use to grab all of that data for our web application, and its average CPU time is really good. Here's the insert that I use to populate that data, and then there's some system queries that we're running. And I can look at query plans. Again, there are management views for a lot of things, so I can look at the query plans here. And more and more with the management views. So they are available. There's documentation out on MSDN for the dynamic management views in Windows Azure SQL Database. But it's similar views to what you have on premise in SQL Server. And then there are a couple of things that are restricted based on the fact that it is a multi-tenant service. Now we also have the event tables, and so I can see connection statistics using this sys database connection stats view. And so here's our HTML5 cars database. Here's a history of the connections that we had to our database, and you'll see a couple of these. We had some failures. We terminated connections here. We have a count of the successful connections as well. And we have some failed connections as well as terminated connections. So that will give you a list of here's the connection, here's the start and the end time on that connection, and here is the status of that connection, whether it was successful or failed or why it failed. Now, if you want to go dig into the event log as to what was happening, then you can take a look in more detail and see here's some connections, successful connections. Let's go see if we can find a failed connection here. There's a failed connection. And in this case, we have a message that says Windows Auth not supported, Windows logins are not supported, so we failed for a different reason. We tried to connect with the wrong authentication. In this case, our connection was terminated. Our connection was idle for longer than the system's timeout, and so our connection got timed out and got disconnected. And so you see exactly why our connections dropped using these event views in Windows Azure SQL Database. So those are really helpful in diagnosing performance as well as what's going on with your Windows Azure SQL Database. Now lastly, there are third-party monitoring tools that exist. AppDynamics and New Relic are both great Windows Azure partners that have great monitoring and diagnostics tools that provide great, beautiful portals so you can see kind of what's going on in your application. You can set up alerts to monitor your application. Now, we've looked at things like Cerebrata already, and that's sort of an on-demand, we are going to look at our diagnostic data or our storage data. The same thing with the Server Explorer inside of Visual Studio using the Visual Studio tools, the Windows Azure tools for Visual Studio. These tools are more kind of enterprise-ready tools for monitoring and managing your application performance and uptime. So with that, let's go take a look at how we can quickly get started. I'm not going to walk through all of this for the sake of time, but I can show you how we can get started with these tools. And so I'm going to go select a subscription over here where I don't have these tools already in my management portal. Now in the Windows Azure Management Portal, there's this new button on the very bottom. And this new button allows us to subscribe to new services in Windows Azure. And there's also a new service that is the Windows Azure Store. And with the Windows Azure Store, we can find add-ons and application services like App Dynamics, as well as New Relic. Now I'm going to just quickly walk through the process for App Dynamics. And you can see we can subscribe to a free light version of App Dynamics. Both have a free version that we can utilize, and we can choose the data center that we want to use. And so what happens with these services is there is a controller that lives out in Windows Azure that your application connects to and provides all of the information coming out of your application that ultimately goes back to a storage account. So if we AzureConf walk through this process, we should be able to subscribe to the free version of App Dynamics. Now when we do that, as soon as this gets created here, you will see a few options light up on the bottom here. And one of these options is connection info, and the other option is manage, which will let you use their management portal and manage your application. I have already got one of these set up, and so I'm going to flip back over to I'm logging in. My session timed out. I'm going to flip back over to the one that I've already got created. And so under add-ons in the Windows Azure Management Portal, you will see the services that you've subscribed to in the store. And I have App Dynamics and New Relic both here. And I have their free versions, the App Dynamics Lite and the New Relic Standard Free. And if I drill into this add-on, there will be an option for us to go to the App Dynamics website for next steps on how to get started. And it will walk us through the process to getting started. Now there's two things that you have to do. You have to download the agent, and then you have to add a startup task to your Windows Azure deployment project. Now in both cases, that's the way it works. If I go flip over to the next steps for New Relic, it's the same kind of thing. Here's my installation instructions. I need their package, and in this case I can do the New Relic installation using NuGet, but I need their package, and I also need to add the startup task into my project. So I'm going to flip back over and just show you how we can do that really quickly. So over in my Solution Explorer, you will see the App Dynamics MSI as well as the New Relic MSI. You will also see two command files. And so this is the App Dynamics command file that you just download from their website, and this is the New Relic command file. Now what we are going to do with these is use these as startup tasks. So whenever our instances start in Windows Azure, those will run first. And so all I do is copy their code in for starting up in their App Dynamics service on my instance in Windows Azure, as well as the same thing for New Relic. And so when I do that, and I deploy that out to Azure with my service, if I go back to App Dynamics, I will be able to drill into a nice portal that will show me what's going on in my application. Now in this case I haven't deployed this out to Azure, but what you see here is a really nice portal for debugging and diagnosing, just like we were doing an IntelliTrace kind of on demand, you will see it historically capture information about your application's runtime and performance. You can also set up things like alerts and that sort of thing, so that it will let you know when things happen outside of a specified threshold that would be allowed for performance. You can trace back transactions end to end, so you can see an order process go end to end all the way through from your application and your web app layers all the way through to the database and back out. And so it does this by instrumenting CLR profiling in your on the server, and that allows it to capture all of that information for your application. So it's extremely useful and really easy to get set up. All right, so before we end here, I want to point you to a couple of things. If you're not using Azure today, there are a lot of ways that you can get started kicking the tires with Windows Azure for free. So use these URLs here, aka.ms/AzureConf-free trial, and that will get you a free 90-day trial. And if you have other benefits with Azure, so if you're an MSDN subscriber, if you're an MSDN Ultimate subscriber, you get up to $6,500 a year in Azure benefits included in your MSDN Ultimate. BizSpark, the same way. So if you're not using Azure, there's no reason you shouldn't be. There's plenty of offers out there for you to get started for free, including a free 90-day trial. So I hope that over the last hour, I've shown you a lot of possibilities for diagnosing your application in Windows Azure, for debugging and collecting what's going on in your application in Windows Azure. So Windows Azure Cloud Services is truly an awesome platform as a service. It gives you that abstraction over the data center without you having to remote into VMs and configure the OS and configure middleware and runtimes, but you still get great visibility into what's going on using things like Windows Azure Diagnostics. And so definitely configure Windows Azure Diagnostics if you're creating cloud services today. I'm a big fan of the declarative WAD config approach, but you could also use the object model and the classes to do it imperatively through your code as well. Whatever works best for you. And then lastly, if you kind of go beyond what you need for that diagnostics provides, if you go beyond that and you need more capability, take a look at things like IntelliTrace and the profiling tools in Visual Studio, and take a look at the third parties like AppDynamics and New Relic. Either way, I am a big fan of Sarah Brada and Redgate's Azure Management Studio. So either way, you should be using those tools, I think, when working with Azure. I truly use them every day. So if you have questions after this, feel free to reach out to me. ericdboyd.com is my blog, and you can find me on Twitter. If you have a Global Windows Azure Bootcamp going on near you, definitely check that out. So at the Global Windows Azure Bootcamp, everyone will receive a free copy of Sarah Brada's tools. So if you have one close to you, definitely check that out. If you don't have a bootcamp close to you, ping me on Twitter, follow me on Twitter, and send me a direct message, and we'll see what we can do to get you some deals on Windows Azure tools with Sarah Brada and Redgate. Thank you guys very much for your time today, and have a great rest of AzureConf.